Hi, welcome back. This is Foundations Enterprise DevOps Secure Coding Practices. My name is Dennis. Let's go ahead and get started. Our learning objectives for today include understanding common security attacks on applications and services, how to apply input validation as code requirements for untrusted data, use security-focused code linters, as well as static analyzers as well. So some security concepts. My background is in security, so we'll cover deeply into what it means from a security perspective and how to look at a security lens from a DevOps perspective. Let's go ahead and get started. Ultimately, a lot of security professionals and security strategic leaders focus on risk. What is risk? Well, risk is something that you define as threat times your vulnerability, usually in a quantifiable manner. Qualitative manners are usually low, medium, high from a human perspective. Now, your risk scale really depends on your risk tolerance or risk tolerance within your enterprise applications. So, for instance, if you want to quantify risk, you utilize a scoring capability from a threat side as well as the vulnerability side. Remember that risk is just risk. It doesn't mean that it's always going to be exploited. It just means it increases your likelihood of being compromised or exploited. The important thing to drive home is that you're always going to measure risk, even if you're not in security itself. Reducing your risk footprint and reducing your threat surface as a whole, reducing the chance for attackers to actually compromise your system is ultimately important. From a configuration standpoint, you have to focus on different layers and you can utilize different items here. So for instance, let's take a look at risk itself. If I want to quantify risk, you as a developer really have a hard time figuring out, well, what does that mean? Well, in this case, you would use something like an OWASP framework or a minor attack method framework. And from this point, you'd probably use CVSS. Now, all the scores are from a 0 through 10, 0 through 9 perspective. So, if, for instance, your threat is 1 and your vulnerability level is 3, your overall risk score would be 3 in this case. Now, how that scales and what is considered meaningful to you or what is most risky and tolerable for your organization, again, depends on the risk scale. Because if you have vulnerabilities that add up to 30, let's say you have multiple vulnerabilities that are each and you have 10 vulnerabilities, you have 30 here. Even if you have one threat vector, that's still 30, and that's really a large increase, right? So even though you might have one threat, you still may have 30 vulnerabilities at 3 medium levels each, thereby increasing your risk score to 30. What does that mean to you? Well, you're not always going to have a risk score of 100. Maybe some organizations allow you to have up to 200. Again, depends on your total risk score. Your cybersecurity team will help you out with this. But understand this. Risk is the measurement of threat times vulnerability, right? If you don't take away anything else from here, take away the formula. Risk equals threat times your vulnerability. How you qualify and quantitate that, it's up to you and your organization. Really, your security team will help you guide some of this. Now, risk is that measurement. However, security is the implementation, right, of controls. Compliance, on the other hand, is the how well have you implemented your controls. All three different aspects and concepts. Keep that in mind as you go forward. Now let's go back to SDLC, Software Development Lifecycle. You have 6 different phases. How do you bake in security to each phase? Well, you have analysis, which you could do for design right here, saying you could have threat modeling. You could have compensating controls, such as firewalls, IPSs. You could have penetration testing. And then finally, you have deployment maintenance, which could include monitoring. And for some of you that have been around security teams, this is usually DFIR, which is the acronym for Digital Forensics Incident Response. Now, this is all easier said than done. Think about this for a second. How can you bake in security at each layer? Which ones can you control? And which ones are out of your control as a developer? Take a moment to pause. Go back to the other slide if you need to. I'll wait. All right. Hopefully you've had that in mind. Let's move forward and think about how we can align ourselves to the actual Scrum process. Remember, in the Scrum process and implementation of Agile, we have sprints. And those sprints are anywhere from 1 to 2 weeks. And then you have these reviews and you have planning sessions and you have a daily check-in and stand up for your engagement. So how do you align each phase with each traditional backend? Because technically, in your implementation, you can have all of what we had right here, right? All of what we had in the previous slide. So let's look at it a little bit more in an organized, tabular fashion, easier for humans to conceptually understand. But sprint and security tasks. So how does this align? Well, in your SDLC phases, your sprint planning phases are mapped into one, or mapped into three here. You have your implementation phase, which is a one-to-one in most cases. And then test and integration is part of review, and then retrospective maintenance. What are the tasks that you're going to commonly see in your workflows across all of them, which your security team will help you with? Or if you're just by yourself, this is what you can do or recommend as part of the ongoing requirements for baking in security from day one or day zero, depending on who you talk to. You want to have approved controls and guidelines, hopefully, that are part of your planning. So, what technology stacks are allowed, which ones are off limits, what kind of patterns, such as are you supposed to be a full VPC, or do you have to go all containers? Must you have a load balancer in all times and not having direct access to the API? In your analysis, you might work with different teams for risk assessments and architectural review to understand that you're meeting all controls from above. And then you might have a threat modeling session with your other security team or just by yourself. Tools like OWASP Threat Dragon, the Microsoft SDLC threat modeling tool can help you with this. You also have the implementation of your controls that you've agreed to with your architectural review process. Of course, we just talked about this penetration testing and continuous adverse monitoring, such as the DFIR teams, such as CSERT, SOC, and then vulnerability scanning teams. Take a moment, pause the video, flip through back to the different slides to make sure that you have a thorough understanding of what kind of tasks and where they align to. Moving on, understanding the tasks are important, but from a DevOps standpoint, you're not the security expert. You will help implement security and reduce risk factors. However, understanding the security's version of CIA triad, which means confidentiality, integrity, and availability. Modern testing might showcase AIC instead. Depends on when you took this actual course. And of course, we have different frameworks. So, how do you implement security controls from a pillar standpoint? So, pillar, right? You always want to have in your system at every layer confidentiality, which means encryption in most cases. Availability, preventing against denial of service, which means having high availability, such as a cluster, multi-geographical spread, and finally integrity, including ensuring that you're patching against exploitable vulnerabilities, hardening your systems, and reducing authentication via least privilege. Now that's from a defender standpoint. If you cut the screen in half, you can also think about it from a threat vector standpoint, or the MITRE ATT&CK framework. From here, you can figure out how penetration testers utilize some of the common examples. Now, these are not every single use case or test case in stone, but these are the most common techniques that you can actually use taxonomy against. From a threat modeling perspective, you might actually utilize this as your threat model to understand all the vectors and mechanisms that can compromise any of the three pillars above. One of the most important things about being a developer is that you're trying to prevent code injection. Right? Code injection is probably one of the top issues around most vulnerable exploitable services and applications, such as buffer overflows, format strings, and although you may not be the security expert, you must guard against this. Let's take, for instance, our vulnerable code using some injection execution here. I have a simple calculator that says, hey, tell me an expressive statement, and I'll give you the calculation for you. Simple code here that we're saying, hey, we're going to input validate that you're going to have a mathematical operator at all times. Your input cannot be 0 or the length of 0, so it can't be blank. And then you also must make sure that that your string or your string that you input can be calculated as a whole. Okay, sounds pretty good. So what's wrong here? Well, if we enter 10 plus 1, we get 11. Sounds pretty straightforward. And we're making sure using our if statements that we learned earlier in test cases, we're filtering out anything that doesn't have the PIMDOS type solution. So multiplication, addition, division, exponents, and subtraction. Now divert your attention to right here. Now this is going to be a wraparound. The true is actually supposed to be at the end right here, but for the sake of argument, let's say I don't put 10 plus 1. Let's say I put sub.process, subprocess.run, and then I have a minus right here, minus L, which is going to be interpreted as a input validator. And I list my whole directory right here. I've just injected, right, my process right here and made it do something I didn't want it to do, even though I had input validation up here. That's because I was actually focused on not the right input validation. Now, this is still important that you should have filtration up here, but I'm not fixing something, right? I'm not fixing the actual issue. I'm fixing a symptom of the issue. So what is the root cause? Let's go forward and understand where the root cause is. Okay, well, let's say I don't know any other method. And I'm going to say, oh, well, why don't we say we also have to maybe include this, and we're only going to use instead of subprocess. I'm taking away subprocess, even though it shouldn't be used. And I'm going to say, hey, math, I want to have a feature enhancement. So you can have cosine and pi and all the functions in there. And if I take away subprocess, the symptom that we used last time to inject, right, you shouldn't be able to do anything bad on my system at this point. We'll see. Now, here, I've added the parentheses as part of the pass listing, and I've changed subprocess to math, saying you can only have math stuff. Uh-oh, I can inject myself again using dir, which is a built-in function, and then the object, which is math, and now I can enumerate all the methods I have, which is still quite a bit. So if I had a vulnerability in the math package, depending on my version of Python, and the vulnerability was restricted to trunk right here, I could actually say, now I can use trunk and then exploit that vulnerability to code execute or do some privilege escalation. You might be going, well, let's say we have 0 vulnerabilities inside the math library. So what? You just can see that you can use all these cool functions right there. Let's take a deeper dive into what penetration testers and red teamers do to actually do additional code exploitation and injection. It's still vulnerable to injection. Now here, I've utilized a variation of this. In this case, I say, hey, execute. This is actually a wrapper right here. So this open bracket should actually be right here instead. But because it's so long, the screen will wrap it through it. Never mind that. I say execute import subprocess. I have an OR statement. And I'm going to run this. I'm going to run the LSL again. And again, I've compromised it even despite not having the subprocess item here. Why? Because we didn't fix the actual root cause. We fixed a symptom of it. I've still have my dash in here to say I passed the whitelisting. And the interesting part is exec returns, the exec function returns none. Okay, returns none. So from a true standpoint, if you're evaluating an expression, or, right, 0 or 1 is still true. Think back to your previous section. Because this is 0, right, a false or none, and a 1 is a true, you only have to have one side that's true, it's going to execute this, even though this returns none, because you've already done the import into memory. Now, I'm going to clear that for a second. Take a look at that code again. Now look at this code. Take a moment to pause there and understand why that is still executed with the OR statement. I'll wait. Now you might be wondering, after looking at all that, well, what do we fix? What is the actual root issue? Let's look at our line here, or one line that does the magic. We have our magic actually right here. Eval. Because why? We're actually not doing any static calculation via a function, eval will do this for us as if we were in the inline interpreter. So how do we fix that? Well, we can still keep our input validation from a symptom standpoint up here. That's okay. It's still a good layer. You should always do security in layers. However, in the eval statement, which is a dangerous statement by itself, you need to add additional parameters. Notice I put it in one line, so you can actually have built-ins, none. I'm sorry, my my items are terrible here. And another nested one, which is maybe not a nested one. We also have math, and then math. Now these are two separate dictionaries inside Python. And this is the equivalent of you doing this in like the JSON equivalent. But never mind that for now. Focus on what we have here. If you recall in the previous sections, as you analyze some code, which was ironically Chow encrypt, I left an Easter egg there for you inside the comments. And if you notice them, this should come ring a bell for you. I'm using eval with filters, right? Because the eval statement, even though I have filters up here, it's not actually correcting my actual input validation error. I want to make sure that you should only use the calculations as possible. Now remember, built-ins means built-in functions. So you might be going, well, wait, how can my eval work if you are going to take away my built-in functions? That's okay. It means, remember, your built-in functions are anything like print, right? If it has that parenthesis at the end, it's a function. However, built in, it'll still evaluate mathematical expressions without any functions. So I can say none right here, and you're only allowed to use the math library. Now, I put my input right here, and I get a return of my modulus for 10. No remainders. Very cool. Now, if I try to inject that one last time, notice that I'm not a wrap, it's not wrapped over here, so you can actually see the full context. It fails out because why? I can only use the math module. Now, some might argue, wait, why is Python giving you an error message like that? Could that be used as an attacker to gain more information and glean it? Yes. However, you're restricting them to pretty much only the math item. If it was still vulnerable, you'd still be able to see that you can enumerate the math module anyways. And while you can't stop against all vulnerabilities from that perspective, let's say your math module still has vulnerabilities based on a version, make sure you patch it in your runtime. So when you do your containers, you do a pip freeze, requirements, right? And then you do a pip, and then you make sure you use the correct version, which could be math, version, I don't know, 10 or something like that. Something that's already patched the issue. Then you build your container based on that, and you're greatly reducing the issues. Now, another common effect of injection-based attacks is buffer overflows. Now, we're not going to go into huge detail in this class. You're not a reverse engineering class, and you're not a security professional. That's okay. Maybe you'll become one day in the near future. The important thing to remember is that memory is, and from a stack perspective, grows upward. And then the memory addresses going higher and lower are growing up. So as you add more stuff going, x equals bar, and then y equals hello, right? It's stacking up. That's why it's called a stack. It's going up bound. And in terms of a buffer overflow, now Python doesn't necessarily have this issue directly, although existing modules could have the same issue. If you have hello, and it should only be a maximum of 12 characters, and you're using a insecure module, regardless of your programming language, if you enter in more than 12 characters, you start to overwrite other aspects of frame. We call these stacked frames because the computer takes the CPU and has a pointer that says, which is called EIP. Sometimes in a 64-bit system, this is also called RIP. The frame says, hey, I need to execute this memory address now, whatever's in here, or return from a function such as main back to up here or back to up here. Now, if that's confusing, don't worry about it. Just remember that data grows upward, but if you overload that data, so if you're more than hello should be, it starts overriding down here. So smashing downward, growing upward. We grow up, but we smash down for buffer overflows, like Hulk smash, Dennis smash, smashing your hammer on something, whatever it helps you with. When we stack, again, what is our stack smash? Well, we have memory addresses in here. And this is an example of a 32-bit operating system or 32-bit CPU, because we have 1 byte across each, byte 0, 1, 2, and 3. Each of these contains a memory address where to execute the next line of code. And because we're Intel x86 64-bit architecture, or in this case 32-bit, it's going to be read backwards inside memory. So basically, endianness just basically says big endian is what we do for humans. We have left to right using largest numbers, and that's what it means to us. The large numbers to the left, the insignificant ones to the right. In computers, most modern computing architecture, it's the reverse. So 1, 10, 100, even though it's still 111, is interpreted in the memory like that, backwards. Now, we don't want to get too caught up in that. And your takeaway here is that if I loaded it with a bunch of A's, I'm smashing downward, and now I've overwritten this stuff. An attacker can utilize their version of this and say, I have attacker code right here. Change the return pointer to say, execute the code up here. Right? Execute my code, my malicious code up here, which in my case, the last time I injected it could have been ls. Okay? That's all it really means. So how do you mitigate a buffer overflow? Well, in Python, even though we don't have a intrinsic issue, you could utilize methods and libraries that have this issue. So the best thing to do is make sure you limit exactly what you're looking for as plus the type of data that you're looking for. So if I'm supposed to say, hey, hello should only be hello, right? It's going to be 4 characters long or 5 characters long. So this would actually be changed to 5. Now, if I put hello world instead, then I have an error right here. And that's all you really got to do. Make sure you limit to what is reasonable within your buffer whenever possible. This is a best practice. So, tips of the day as you come around here. Limit the number of characters as the input, right? User input is untrusted always, as well as the limitation of your type of input whenever possible, right? All right. So keep those 2 pointers in mind as you go through your coding. Let's take a quick break and get back to our next section. All right, welcome back. I hope you had a great break. Let's get to our section 2, which is mitigations. We looked at some mitigations already using at the code level, but what about everywhere else? Remember that baking in security has to happen at all layers using our CIA triad, right? Confidentiality, integrity, and availability. You can't just do it at the code level because your code runs on what? Systems. For that, we help you with defense in depth. It's a strategy that says you do security in layers. So your first layer right here, you as a developer can help this directly, which is prevention of insecure code to start with. Using confidentiality pillar using encryption. Input validation is part of another threat vector to help you with the integrity. And availability might be to have try else to have no errors gracefully. If you're not using serverless, remember the security still has to happen regardless if you're server or serverless or container. It's just that someone else is doing this for you. You also have the host layer, right? So you have infrastructure that you have to keep, patching up the OS, antivirus, hardening. You also have network security, which includes intrusion prevention systems, firewalls, and then finally, physical security, which is usually out of both of our hands, whether you're in ops or dev, or altogether DevOps. So CCTVs, badge access readers, data centers will have listing requirements of who's allowed in and out, and administrative controls. What are considered best practices? Do you have to have changes and change management before you actually implement something inside your code? All these layers are part of defense in depth, and something that you should truly consider as part of your uh, combining with your CIA pillars. So remember, you have CIA right here, CIA right here, and onwards. If anything else, just remember CIA is everywhere. Pun intended. All right, code layer. What can you directly impact? We saw this a little bit earlier in the earlier sections. Making secure code using input validation. Now, what is one extra code defense that you could have here? Well, let's say you have a statement and you don't want to have the overload your system. Well, you could have an input requirement of having a length of no more than 100 characters. Now, the math expression, well, that's not a lot but for simple complex statements, you could do that too. Make sure you have input validation at all levels of your code, not just at the symptom layer, which you have untrusted here. You also need to have it at the execution side right here. Format your code, make sure that you can only have what you're looking for, and utilize secure functions. Eval is not a secure function out of the box. This is a compensating control to help you make it somewhat more secure, but there are more secure alternatives to eval. You'll see this later on in your labs. What about the system layer, the host layer? Well, you have the CIS 20, and at the time of this recording, it's also called the CIS 18 because they minus 2 from it. So, but they've consolidated. But notice that the majority of us in the industry know it as CIS 20 or Center for Internet Security 20. These are the top 20 controls you should have at the system level, including patching, system hardening, and other like-minded items that you need to have for security as a whole. Remember, CIA at all layers. We also come on to network layer. So, what are some technologies? IPSs, firewall rules, ACLs. The security group is what versus a network ACL? Ah, yes. This is the equivalent of having a host-based firewall as opposed to a network-based firewall. Take some time to understand what the security components are in this picture. Now that you've taken some time to understand, am I missing something? Oh yeah, I'm missing the IPS. And a WAF, which you would actually put either usually right here before the firewall or after the firewall. Now we also got that VPC inherently in itself, if you're using natting or a elastic ELP load balancer, it's also another layer of security from the network perspective. And finally, remember, high availability is important. So remember our HA clusters, value at 1 from an active standby perspective from our networking segment. Now, remember that at all layers, including containers, your containers must have security. So make sure you don't utilize inappropriate commands, old utilities using your Docker file, because your container can still have, when you push it back up to the registry, you can still have vulnerabilities at runtime and the libraries are associated with that runtime. Keep that in mind as you go to the lab. All right, that's it for now. Take a break, get started on your lab, and we'll see you in the next lecture. Thanks for listening.